We've instrumented open source crypto exchange with TrueWatch observability. So crypto exchanges are interesting because they handle high stakes, high volume transactions. So even a slight performance issue can lead to failed trades, poor user experiences, and eventually revenue loss. This is why observability is not only essential, it is critical for such a business. So I'll show you how TrueWatch can be instrumented to such an application, from RAM, real user monitoring, to APM, application performance monitoring, to profiling, to identify the root cause of an issue. So let's begin. So imagine I want to withdraw the crypto and specify a withdrawal address. And once it's submitted successfully, the user doesn't see the transaction in the history. So this issue has been reported to the support team. So as a platform support engineer, I'll use TrueWatch in this way. So I customize a dashboard to monitor the performance of my application. And this is mainly from the user experience side of things, and more importantly, at the service. From this dashboard, I can see over the past 3 days. These are my service health. In terms of online services, these are intended 9 services, and then across 33 containers. On the right, I can see that there's an error that's flagged out. And then also in terms of response time, there are some services which are taking a while. So these are areas of interest. If let's say the user reported an issue on latency, I can zoom into latency later. But just to walk you through, we monitor the 4 golden signals. We have saturation, errors, latency, and traffic. So at the saturation level, I can see that my container saturation is healthy. It's all below 20%. And memory usage as well. And these are trends, right? Historical time series data. So no issues here on saturation. Errors, this one error is probably attributed to the off service, which I can choose to also drill down and explore deeper into this keycloak error, right? So I can also run AI error analysis on it. So it'll give me an initial diagnosis and potential resolution for this error. Right, so I can also move on to latency, which is more important with regards to the user complaint. So I can monitor user journey here. They are all okay. But if I look on the right, in terms of API response duration, and this is the 90th percentile, I can see that one service stood out, right? So it is taking longer than usual. So it's flagged out here. And then I can drill down deeper into this resource path, right? So I can see over the past 3 days, this one stood out, and then I can click and dive further into the session. So this is RAM session replay. So I can see this is the user. I can correlate it with the user who reported or raised the issue. And then to make sure that this is the right user I'm looking at, I can trace his actions before and after. And then I can also drill down. Let's say if the reported issue is related to withdrawal request, I can zoom in further to look at the trace details and look at the HTTP requests, and I can sort it by descending order. I can see that this request endpoint, this path, is returning 200, but the latency is slightly higher compared to the rest. So I can view related trace, where I get the flame chart for my service-to-service calls. And then I can see that this is running Java on the backend. This is a controller. Then I can note the controller method. I can also correlate with the host that is running on for this particular service, which is an OPEX wallet. And then I can look at the saturation. So I can do in the process of elimination. I don't see an issue here. I can look at logs. And it's filtered by the service as well. I can see that there's some Fibonacci running, and there's a spin weight function that's completed based on the logs in this container. So I can correlate with network as well. And I can move up a layer to examine, let's say, the code hotspots. Right? So within code hotspots, I see that CPU time is slightly higher, and then I can zoom in to the call stack. right? This is under profile function to function calls within an application. I can paste the function name here as I copied earlier and can zoom straight into the function, right? I can see in terms of percentage wise, it's taking 94.66% of the total, which is quite significant in terms of CPU runtime. So it states that this package is under Cornelian OPEX wallet app dot controller and line 112, right? So I want to examine it further. So I can either pass this URL, this link, screenshot and references to the engineer, or if I have access to the source code, I can into the source code and examine. So down here, I can see this is the package, and then I look at line 112. Line 112, we have a spin wait function that's executed that caused the delay, and then subsequently it also printed a line which corresponds to the log that we have seen. So as you can see, we can trace from the front end, the session replay, all the way down to the source code level to identify the root cause of the issue very quickly, just within a couple of minutes from the TrueWatch interface. Right. So going back to this dashboard, this on the latency side, then I can scroll down further to examine and plot custom charts and set thresholds in terms of SLA and SLI threshold to monitor, especially if you're running microservices and APIs, right, across different teams. So this is critical. So in terms of traffic, we can see the service map across the different services, and then the service request as well. So we have a couple of synthetic tests instrumented here, mainly to illustrate the point that we have synthetic test and monitoring, and this relates to SLO monitoring because companies, especially financial services, we have strict SLAs to comply with. Okay, so from here we have also SLO monitoring because the exchange, let's say we use third-party service from Binance, and we want to track our partners' SLA or SLOs, right? We can instrument and we create an SLO based off SLI in terms of availability, endpoints testing, and then we can set a target compliance rate, right? So take this example of the partner service. We have set availability of 99.95% uptime within a year. So in terms of 365 days, the remaining budget is only 4 hours and 22 minutes. And as you can see, this partner has exceeded the budget already by over 3 days. Right. So we have SLO tracking and monitoring as well. There are much more features that are available on the platform, multi-step API tests, etc. But in the scope of this video, what you can see is that we can quickly identify the root cause of an issue from the session level, from the front end, all the way down to the code level. And this helps in reducing your mean time to resolve issue, right? So, and ultimately it's shorter. And then if, let's say, systems go down, the result, and then in terms of SLO, SLA, the error drawdown is less if it takes faster. So these are some of the value proposition that TrueWatch has to offer from an MTTR, MTTD, root cause analysis standpoint. So that's all for today. Thanks for watching.